Right, so this is part 3 of Vitalik's What I Would Love to See My Wallet. So continuing, so one advantage of this technique is that it is a natural pathway to not just privacy preserving asset transfer, but also privacy preserving identity. Identity happens on-chain already. Any application that uses proof of personhood gating, example Gitcoin grants, any token-gated chat, the Ethereum Follow protocol, and much more are all on-chain identity. We want this ecosystem to also be privacy-preserving. This means that a user's activity on-chain should not be collected in one place. Each item should be stored separately, and the user's wallet should be the only thing with a global view that sees all of your attestations at the same time. A natively many accounts per user ecosystem helps accomplish this, as do off-chain attestation protocols like EAS and Zupass. This represents a pragmatic vision for Ethereum privacy in the medium-term future. It can be implemented today, although there are features that can be introduced at Layer 1 and Layer 2 to make privacy-preserving transfers more efficient and reliable. Some privacy advocates argue that the only acceptable thing is total privacy of everything, encrypting the entire EVM. I would argue that this may be ideal as a long-term outcome, but it requires a much more fundamental rethink of programming models, and is currently not at the level of maturity where it is ready to go and deploy across Ethereum. We do need privacy by default to get sufficiently large anonymity sets. However, focusing first on making transfers between accounts and identity adjacent use cases like attestations private is a pragmatic first step that is far easier to implement and which wallets can get started on today. Ethereum wallets need to also become data wallets. One consequence of any effective privacy solution, whether for payments or for identity or other use cases, is that it creates a need for the user to store off-chain data. This was obvious in Tornado Cash, which required users to save each individual note, representing a 0.1 to 100 ETH deposit. More modern privacy protocols sometimes save the data encrypted on-chain and use a single private key to decrypt it. This is risky because if the key is ever leaked or if quantum computers ever become viable, the data all becomes public. Off-chain attestations like EAS and Zupass have an even more obvious need for off-chain data storage. Okay, so wallets need to become not just software to store on-chain access permissions, but also software to store your private data. This is something that the non-crypto world is increasingly recognizing as well. Example, see Tim Berners-Lee's recent work in personal data stores. All of the problems that we need to solve around robustly guaranteeing control of access permissions, we also need to solve around robustly guaranteeing accessibility and non-leakage of data. Perhaps the solution could be overlaid together. If you have end guardians, use M of N secret sharing between those same end guardians to store your data. Data is inherently harder to secure because you cannot revoke someone's share of it, but we should come up with decentralized custody solutions that are as secure as we can. Okay? Secure chain access. So I'm learning along with everybody here because right now a lot of this stuff is very interesting to see what he's saying. And mind you, he's been at this since 2013. Before then, so this is all this is like great learning material for all of us. So secure chain access. Today wallets trust their RPC providers to tell them any information about a chain. This is a vulnerability in two ways. The RPC provider could attempt to steal money by feeding them false information, example about market prices. The RPC provider could extract private information about what applications and other accounts a user is interacting with. Ideally, we want to plug both of these holes. To plug the first, we need standardized light clients for Layer 1 and Layer 2s which directly verify the blockchain consensus. Helios already does this for a Layer 1 and has been doing some preliminary work to support some specific Layer 2s. To properly cover all Layer 2s, what we need is a standard by which a config contract representing a Layer 2 also used for chain-specific addresses can declare a function, perhaps in a manner similar to ERC-3668, containing the logic for obtaining recent state roots and verifying proofs of state and receipts against those state roots. This way we can have a universal light client allowing wallets to securely verify any state or events on Layer 1 and Layer 2. For privacy, today the only realistic approach is to run your own full node. However, now that layer 2s are entering the picture, running a full node of everything is getting increasingly hard. The equivalent to a light client here is private information retrieval. Private information retrieval involves a server holding a copy of all the data and a client sending the server an encrypted request. The server performs a computation over all the data, which returns the client's desired data encrypted to the client's key without revealing to the server which piece of data the client accessed. Okay, so you have the client, encrypted requests, big database D, big D, database, encrypted response, and D, client. Okay. Cool. To keep the server honest, the individual database items would themselves be Merkle branches, so the client could verify them using their light client. Okay. PIR. Geez, he just taught. Private information retrieval is very computationally expensive. There are several routes around this problem. Brute force. Improvements in algorithm or specialized hardware could potentially make PIR, which is again private information retrieval, fast enough to run. These techniques may depend on pre-processing. Servers could store encrypted and shuffle data for each client, and clients could query the data. The main challenge in the Ethereum setting is adapting these techniques to datasets that change rapidly as the state does. This makes real-time computational costs lower, but may well make total computational and storage costs higher. Weaken the privacy requirement. For example, each lookup could only have 1 million mixins, so the server would know 1 million possible values that the client could have access, but not any finer granularity. Multi-server PIR. PIR algorithms are often much faster if you use multiple servers with a 1 of n honesty assumption between those servers. Anonymity instead of confidentiality. Instead of hiding the contents of the request could be sent through a mixed net, hiding the sender of the request. However, doing this effectively inevitably increases latency, worsening the user experience. Figuring out the right combination of techniques to maximize privacy while maintaining practicality in the Ethereum context is an open research problem, and I welcome cryptographers trying their hand at it. Ideal key store wallets. Aside from transfers and state access, one important workflow that needs to work smoothly in a cross-layer 2 context is changing an account's validation configuration. Whether changing its keys, example recovery, or a deeper change to the account's entire logic. Here, there are 3 tiers of solutions in increasing order of how difficult they are. Replayed updates. When a user changes their configuration, a message authorizing this change is replayed on every chain where the wallet detects that a user has assets. Potentially, the message format and validation rules can be made chain independent, so it can be automatically replayed on as many chains as possible. Key stores on layer 1. The config information lives on layer 1, and the wallet on layer 2 reads it with an L1S load or remote statistical. This way, updating the config needs to be done only on layer 1, and the config becomes effective automatically. Key stores on layer 2. The config information lives on layer 2, and the wallet on layer 2 reads it with a ZK snark. This is the same as 2, except key store updates can be cheaper, though on the other hand, reads are more expensive. Alright, so this is like getting into the nitty gritty of things. Bob's address 2, Bob's address 3, Bob's key store contract, rules for changing the public key. Solution 3 is particularly powerful because it stacks well with privacy. In a normal privacy solution, a user has a secret, a leaf value is published on-chain, and the user proves that L equals hash and N equals hash S2, S1. Okay, for some never revealed secret they can control, the nullifier N gets published, making sure that the future spends of the same leaf file without ever revealing L. This depends on the user keeping S safe. Is anybody else trying to figure out what this means? Like, for real. A recovery-friendly privacy solution would instead say S is a location, example address and storage slot, on-chain, and the user must prove a state query L equals hash S load S1. Okay, so I understand. So you want to access this PIR, and in order to do so, you need a formula, and that formula is figuring out L while giving you and then you have N, and you have to figure out L. And keep it private. I guess this makes sense. I mean, we're getting to the bottom of this now, but it really is a lot to take in for first-time readers of this. So the weakest link in a user's security is often the DApp, decentralized application. Most of the time, a user interacts with an application by going to a website, which implicitly downloads the user interface code in real time from a server and then executes it in browser. If the server is hacked, or if the DNS is hacked, the user will get a fake copy of the interface, which could trick the user into doing arbitrary things. Wallet features like transaction simulations are very helpful in mitigating the risk, but they are far from perfect. Ideally, we would move the ecosystem to on-chain content versioning. A user would access a dApp via its ENS name, which would contain the IPFS hash of the interface. An on-chain transaction from a multi-sig or DAO would be needed to update the interface. Wallets would show users if they're interacting with a more secure on-chain interface or a less secure Web2 interface. Wallets can also show users if they are interacting with a secure chain, example stage 1 plus multiple security audits. For privacy-conscious users, wallets can also add a paranoid mode, which requires users to click through accept HTTP requests and not just Web3 operations. Okay. A more advanced approach would be to move beyond HTML and JavaScript and write the business logic of dApps in a dedicated language. Oh, perhaps a relatively thin overlay over Solidity or Viper. Browsers could then automatically generate a user interface for any needed functionality. OK Contract is doing this already. Another direction is crypto economic info defense. dApp developers, security firms, chain deployers, and others can put up a bond that would get paid out to affected users if a dApp was hacked or otherwise harmed users by acting in a highly misleading way. As determined by some on-chain education DAO, the wallet could show a user a score that is based on the size of the bond. The longer-term future, the above was all in the context of conventional interfaces, which involves pointing and clicking on things and entering things into text fields. However, we are also on the cusp of paradigms changing more deeply. AI, which could lead us to moving away from a point-and-click entire paradigm to a paradigm of say what you want to do and the bot figures it out. Instead of point and click, you say what you want to do and the bot figures it out. Right. I want to go on this website and the bot just goes on the website for me. Oh my goodness. Brain-computer interfaces, both mild approaches like eye tracking as well as more direct and even invasive techniques. Clients engaging in active defense. The Brave browser actively protects users against ads, trackers, and many other undesirable objects. Many browser plugins and crypto wallets have entire teams actively working to protect users against all kinds of security and privacy threats. These kinds of active guardians will become only more powerful in the coming decade. These three trends together will lead to much deeper rethinking of how interfaces work. Through natural language input, eye tracking, or eventually more direct BCI, together with knowledge of your history, perhaps including text messages, as long as all data is processed locally, a wallet could get a clear, intuitive idea of what you want to do. AI could then translate that intuition to a concrete action plan, a series of on-chain and off-chain interactions that accomplish what you want. This could greatly reduce the need for third-party user interfaces entirely. If a user does interact with a third-party application or another user, the AI should think adversarially on the user's behalf and identify any threats and suggest action plans for avoiding them. I'm learning a lot. Are you? Because this is like really great information. Ideally, there would be an open ecosystem of these AIs produced by different groups with different biases and incentive structures. These more radical ideas depend on technology that is extremely immature today, and so I would not put my assets today in a wallet that relies on them. However, something like this seems to be pretty clearly the future, and so it's worth stating to more actively explore in that direction. Wow. Okay, so that's really it for this wallet. Well, he wants to see in a wallet, so I understand where he's coming from, and my opinion on this is like, okay, like a lot of this stuff is a lot of like, I need to understand a lot more about this, but what I liked is when he started talking about the AI, like right here, the longer term future of, because like that was like actually right, because like right now all we're doing is pointing and clicking, but I can envision a future with these AI agents where it's like you type in, okay, I want to go on Vitalik's website and I want to see the most recent article that he has, and the bot does all that for you. and it brings it up, and you're like, wow, and now you're there. Or you're like looking for a movie you want to watch, and like, find me this movie online that I can watch right now for free, right? So now the bot just goes on the website, on the internet, and starts looking for that movie. This is really impressive. So you really got to be on top of this stuff. So like, I'm really focused on this crypto information to come, and so we're going to be doing a lot more crypto videos in the future. So stay tuned for that.